Right. Good evening to you all. Uh, so talking about database, databases and electronic databases, right? So in the last class, we started to discuss about database and I gave some basic things. So basics about databases. So hope you remember the things which we discussed on the other day. So I started off with the word database. So I defined the term database first. Then we took the types of databases, right? Database can be exist in two types. So I explained about those two types. Yes, I provided some examples for both databases, both manual database as well as electronic database. Then we discussed about the differences between manual database and electronic databases. Right? There are so many differences between these two. We discussed the differences. Then we went to take the term database management system, DBMS. Right, so I explained about DBMS. Hope you remember that the things which we discussed earlier. So DBMS is an application software used to create and manage electronic databases, right? So whenever you want to create a database in your computer, you must use an application software called database management system, right? I gave some examples for database management system too, right? So these are the things which we discussed on the other day. For exams, these are important, even though they are basics, they can be asked in the exams too, right? So today we can proceed from this point, right? As I said earlier, everything that we studied in the classes, in the previous classes, are important for proceeding to the next classes, right? So whenever a lesson is finished, try revising that one and understanding the things which we discussed, right? So before I start, start the today's lesson. So let me take those things or take those, slides again and show the basic idea, right? So I will show them first and then only I can start the today's lesson, right? Right, so I was talking about these things. So we started off with database, right? The definition on the other day. We defined the term. Then we moved to the types of databases. We have manual and we have electronic. We discussed, right? We defined the term manual database and also we took some examples and also I mentioned some of the components used to save the data in manual databases like papers, files, filing cabinets, hope you remember, right? Then we took the electronic databases and defined the term and also we took some examples for electronic databases. After that, we took that most important heading, differences between manual and electronic. Don't try to memorize anything, right? Just understand the things and keep them in your mind. So if it is difference between or differences between manual and electronic, try taking an example in your mind and take the points one by one, right? So you don't need to memorize everything, okay? Then finally we took the term database management system, DBMS. So I already told you that it is an application software used to create electronic databases and it is also used for managing the databases, right? This is the one which I took at last in the last class, right? So examples for DBMS. So we have so many companies, so many producers who produced DBMS software, right? I have listed some of the most popular and some of the most commonly used database management system softwares. Okay, right. So with this, with this revision or with this basic idea, we can start the today's lesson, right? So I hope that you know the term database now, right? You can check, you can understand that there are two types of databases, manual and electronic, right? Okay. Hereafter, we will be focusing on electronic database only, because as I said earlier, creating a manual database, organizing a manual database is too simple, right? Even within overnight, you can create create a manual database. It doesn't take much time, and also it is not the hardest thing to manage it, right? So it's too easy. So there is no need for discussing about manual. There is no need for, I mean, spending hours for studying about manual. So this is all about studying electronic database. Even though I use the word database, it means electronic database. Okay, right. Right. So here, right here, in the definition, I told you for managing the data in an electronic database, we use some objects. Look at the second point. These use some objects to manage the databases. So in an electronic database, you have data. So to manage those data, the term manage includes so many things. So even storing the data in a database can be a management activity. Whenever you need data from database, you have to retrieve that. That is also managing activity. Sometimes whenever you need data, you have to retrieve and print that. That is also a management related activity. So the term management or manage is a common term which can describe so many activities, right? So for managing the data in a database, like storing, retrieving the data, retrieving and printing the data, you need some features. You need some features in electronic databases, which are called objects, right? So an electronic database software like Access or Oracle, they use some features which we call objects, right? So remember these objects, but I will explain the terms one by one later, not now. Maybe from this point, I can explain, or I can start explaining the term table, but not the others, right? So look here, the objects used to manage the database are called database objects. So objects are nothing. These are some features that database management system software has some features. Sometimes we call them as tools or objects for managing, right? So they are database objects, right? So here, there may be many. I have listed 4 of them. You should know these 4, starting from table, that is one of the object, query is another object, form and report. Remember, for this point or for this moment, at this moment, remember these are some features for managing the data. But you don't need to worry about how they manage or how they handle the data. That will be described one by one later. But now I can explain the table, because this is the time to start the table. So I can explain how a table looks like and how to save the role of the table in a database. So I will explain some of the basic things about table, not query, not form, not report, right? They will be taken later, okay? Right, so these are database objects available in database management system software, okay? Right, so let's start from table. So it's very simple. In an electronic database, table is used to store the data in a systematic manner, right? So, in electronic database, what is database? How to describe or how to define the term database? A collection of data. Simply a collection of well-organized data is database. So you all can understand that a database has data, right? Inside of a database, there should be data. So now I can tell you that the data in a database exists in the form of what? Table. So table is a vital component in an electronic database because it is It is for saving the data. That's it, right? So don't think much. It looks like a typical table that you use every day. See, for example, take a look at your timetable table, right? Whenever you want to put the subjects according to the time, you don't need to write them as paragraphs or as points, because you feel that showing them in a table manner is easy to understand and easy to retrieve. That is exactly the same thing, right? I'm talking about such things. That is a table. And also in your subject, rather than showing them as paragraphs or points, sometimes you like to construct tables. That's the one I'm talking about, right? So tables, what's the role of a table in an electronic database? Storing the data. It would be easy if I proceed, if I mean, progress, right? You can understand once things are going, right? Okay, let's take the other one. Okay, let's see a typical table, right? I have shown a simple table here, right? So this is the table for storing students' data, right? So look here, listen to me carefully, because these are basics and also these are important, right? In this table, think vertically, right? Look vertically. So here, look at the first column. This is admission number. I use the term ADNO, admission number. So in the first column, admission numbers are saved. In the second column, student names are saved, because it's a table for storing students' data, right? So it's a student name. Second column has student names. Look at the third column, right? The last column has students' date of birth, DOB. So in a table, listen to me carefully, in a table, the vertical things, vertical components are always referred as columns. Column is a generic term used to describe the vertical components. But here in database, here in electronic database, these vertical things, vertical components are called, right? So you can see the term here, are called what? Fields, sometimes called attributes, right? Attributes, ATTRIBUTES. Attributes means characteristics, right? Attributes. Okay. So what are the attributes, or what are the fields available here? ADNO, admission number, is one of the fields. Student names. So here, when we want to name a field, we don't leave spaces between names, right? Rather than leaving spaces, we use this special character called underscore for joining two words. So here I wanted to put student names, STU names. So I don't use the space there. I have the option to write both names together, like STUNAMES, student names. Sometimes writing two words together, I mean, doesn't make any sense, right? So I want a space there. Space is not allowed. So I put an underscore for joining two words. Remember this. This is the most common scene in field names, having an underscore, right? So student name is another field. DOB is another field. So how many fields are there? We have 3 fields or 3 attributes in this table. These questions are often asked in your MCQ final papers. They may show a table and ask you to find out the number of columns, right? Sorry, number of fields. So you should know what the term field describes, right? So here fields are columns, okay, right? So now think or look horizontally. Just now you have seen vertically and identified those components as fields, right? Now I ask you to, look horizontally, right? Look at the first one. So this is the first one. In our day-to-day life, we used to refer them as rows. Vertical things are columns, right? Horizontal components in a table are always known as rows. This is in practical. But in databases, these rows are called, right? These horizontal things are called what? Records, right? Records. Sometimes called tuple, T-U-P-L-E, tuple. Whenever there is a new name, spoken, try to, write it down. So this may be useful. Tuple. You have to pronounce as tuple, not tuple, T-U-P-L-E, tuple. So every row is referred as a record or tuple. Every column is referred as what? A field or attribute. So tell me how many records are there in the table? How many records which we have? 1, 2, 3, 4. We have 4 records, right? The first student details, right? They are first record. The second student's details are another record, right? Then third one and fourth one. So you have 4 records. Have you understood this basic idea? So this is how a table, constructed, right? So we have fields as vertical components, and also we have records as horizontal components. Okay, right. 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 I have given a small exercise for recalling these things. So there is a table given, date there, book ID there, SID, student ID. Assume that it is a table maintained in a library, because in a library students often borrow the book. So book ID there, the date of borrowed is there, and also the student who borrows the book also listed, right? So imagine this is a table managed in a school library, right? So even without that description, you can find the answer. But I'm telling you to describe that table, right? Okay, look here. How many fields are in the above table? It's too simple, isn't it? This is the format of the question in your final paper. Almost all the past papers, you can see such questions, right? So it's too easy. How many fields are there? So remember, fields are vertical components, right? Don't forget them. So how many fields? Date is one field, book ID is another field, SID is another field. So how many fields which we have? 3, right? So this is 3. You have 3 fields. How many records are in the above table? So what is a record, right? It's a row. It's a row, right? It is placed horizontally. So this is one record. This is another record. This is another record. This is another record. Every record should have a person or maybe sometimes a object's detail. So here, the first record has some information about books and students, right? The second record also has. So how many records are there? There are 4 records. So I hope that you have the ability to identify the records and fields in a given table, right? That's not a tough task, right? That's too simple. Okay, right. So moving to the next one. Right. So look here. So just now I have spoken, or I have used 3 words. I used the word record. I also used the word field. I used the word table. Or in addition to them, I also used the term database, right? I have used 4 words to explain something to you. Just now I have used these 4 words. Let me give a relationship, or let me take a relationship or link between these words. So what I'm going to do is I'm going to take some sort of relationship between these 2 words, right? What are the words to be taken? Record, field, table, finally database. So to take the relationship or to take the link in between these 2 words, we should understand the table again, right? We should study the table and clearly understand the things. Okay, let me take the table again for explaining something, but you have to watch or you have to listen to me very carefully. Then only things will be simple, right? So we listen to me very carefully, right? Look here, I'm taking the table again. So right, so keep an eye on the first record, right? Everyone should focus on the first record. This is the one which I'm talking about, right? I'm highlighting the first record. This is the one. Okay. Now, so we all know that it is a record because minutes ago I explained, right? This is a record. In fact, this is the first record in the table, right? So now let's see how this record is created or how this record is formed. If you are able to understand this one, then you can take one relationship, one important relationship between two words, right? So now we have to understand the first record. In fact, we have to understand the method or the way in which this record is created, right? So listen to me carefully, right? So look at the first record. In the first record, you have 1001, this is admission number. Summon, right? Summon, this is student names. And 15/3/1995, this is date of birth. So now I can say, I'm writing on the bottom, right? Even though, sorry, even though the handwriting is not neat, but you can, you can understand. So I'm writing the record here. So the first record is created using the admission number 1001, right? 1001 plus, I'm using the plus because to show the combination because they all combine together and create the record, right? So 1001 plus summon, it is summon. Okay, plus, what is it? 15/3/1995, right? So it is 15/3/1995. Okay, so when 1001 summon 15/3/1995 are combined together, the first record is formed. Have you understood this point? Right, so the first record is formed as a combination of these three data, 1001 summon 15/3/1995, right? Okay, so tell me what is 1001, what is it? It is admission number. So I write ADNO, right? ADNO, admission number, instead of writing 1001. Earlier I used 1001 directly, but I'm using a common term now, right? Admission number plus. Yes, it's summon. What is summon, right? So in which category the summon belongs? That is student names, right? So it is student names. I simply put ST names, right? Student names. Student names plus. Look here, 15/3/1995. What is it? Look there, look at the top. What is it? The date of birth. So it is date of birth. So now I can say, right, earlier I was trying to say that the first record was created as a combination of, or by adding 1001 summon 15/3/1995. But now I use a common term for those three values. 1001 is admission number, summon is a student names, 15/3/1995 is date of birth. So now I can say that the first record is created by adding admission number, student names, and date of birth. Have you understood? So not only first record, look at the second record. Even the second record also created using, what is 1002? It's admission number. What is Meena? Student name. What is 16/2/1996? Even remember the second record also created by adding 3 fields: ADNO, student names, date of birth. Even the third record, fourth record, doesn't matter how many records this table has, all these records are created as a combination of these 3 fields. So now let me take the first relationship, first conclusion, right? Listen to me, right? So what is the admission number? It is a field, right? It is a field. So let me write admission number as field 1, right? Field 1. I will write, or I will show these things in a systematic manner later, but now I have to explain in written. That's why I'm taking some time. So it is field 1 plus. What is student names? Again, a field, right? So this is field 2. Field, it is field 2, number 2, plus, as we've discussed, date of birth is also added, right? So what is date of birth? Another field, right? So it is field 3, right? It is field 3. So when all these 3 fields are added, right? When the fields are added, what is formed or what is created? A record, right? So a record. So it is a record. Have you understood this first conclusion, first relationship? So now I have come to a most important, conclusion, that a collection of what fields is a record. So collection of fields makes or creates a record. Look at here, the field 1, field 2, field 3. What are they? They are fields. So when they are added together, what is created? Record. Again, I tell you not to memorize. Right? Please understand the things. That's why I have started from the real data. See, I didn't use the term field 1, field 2, field 3 directly at the beginning. So I started off with the value, real values. Then only you can understand, right? So earlier I used 1001 summon 15/3/1995, right? So when they combine together, you all know that it is a record. The first record is created. Then I asked you to discuss, right? So what is 1001? Ask yourself, what is 1001? It's the admission number. What is summon? It's student names. What is 15/3/1995? So date of birth. So I use common terms rather than using the real data, right? Finally, because in this table, admission number, student names, date of birth are there. But in another table, there may be some other fields. In the third table, there may be some other fields. So it is not good to say that ADNO plus student names plus DOB is equal to record, because that is okay, but that is in this table. But we are talking about in general, right? So rather than using admission number, student names, date of birth, I use the word field 1 because that's a field. Student name is another field. So field 2, date of birth is another field, field 3. So when they combine, they create record. Have you understood this idea, this relationship? Okay, right. So now we derived one relationship, right? Okay. Look here. Now look at this. I'm taking all the records together. Listen to me. This one, right? I'm taking all the record. Assume this table has only 4 records. There may be thousands, there may be hundreds, right? But here, in my case, it has only 4 records, right? So now take all these records as a whole, right? If you have 100 records, take all the 100 records together. If you have 1000 records, take all the 1000 records together. How they look like. So if you combine all these records, how it looks like. So this is simply, look here, the entire data, right? So this is simply A table. Look here, I have taken all these data together. So what is it? It is a table. So you don't need to worry about the names, right? Sometimes you may think that the names are on the top and they may, they may be, ignored. But don't worry, this is the table, because table is nothing. Table is a component to keep the data. So now I have combined, or I have taken all the records. So which means I have taken all the data. So it looks like what? A table. So now let me take, or let me, derive the second conclusion or second relationship. So look at the first one, right? 1001 summon 15/3 1995. What is it? It is a record. So in the next line, I'm going to write record 1. I put simply R1, record 1, plus. Look at the second record, 1002 Meena 16/2 1996. It is record 2, right? So let me write R2, record 2. Third one, 1004 Pereira 13/4 1995. What is it? Another record. So let me write a comment name R4, record 4. So plus, since I have one more record, I take it, 1005 Vimal 18/10 1995. What is it? It is another record. Sorry, it is R4, the previous one R3. So when they combine, right, when all of them are combined, as we discussed, it is a table. So what is created as it is a table. Okay. So I have taken 3 words up to now, and also I took some sort of relationship between them. So what's the relationship? Fields, when fields are combined, they create what? A record. When many records are combined together, they form, or they create what? A table. Let me take one more relationship that is also important, right? We have to understand, right? Look, this is a table to keep students' data. Assume this table is maintained in a school. So that school maintains this table to store the students' data. But tell me, does this school have only student data for storing in the databases? Does this table, sorry, does this school have only student data like admission number, names, date of birth, gender, right, address? So are they the only data to be saved in the school? No, never. Because yes, these are important. These are students' data. But you know, if it is a school, there should be more than the students' data. There should be many data. You know, the data about teachers to be maintained. The data about payments, because students often make payments in a school. The data about payments to be saved. The data about physical resources to be saved. So your school has to save a lot of data. Yes, of course, the school has to save the students' data. That is important. But in addition to saving the students' data, the school has the responsibility to save some other data. But do you think, right, do you think that it is good to save all this data in a single table like this? I repeat my question. Is it good to save all this data, teachers' data, payment data, physical resources data, students' data in a single table? Is it the right approach? Can a school do that? Is it the right way? You use your general idea, right? Practical knowledge. You don't need to be an expert, or you don't need to have basic background about database, right? Think practically. Is it the right way to store all these data in a table? Is it the correct approach? Never, right? It is not the right way, because as you know, we have so many different data. Teacher may have different characteristics. Teacher ID, maybe teacher name, right? Teachers, teaching subjects, maybe qualifications. Teachers, data different. Even if it's a payment, they should be different. So if you have a practical, if you have a common sense, you can understand that it is impossible to keep all this data in a single table. So what is the option that school has? Rather than saving all the data in a single table, the school has to maintain multiple tables to store the relevant data. So yes, the students' data can be saved in this table. There should be another table. So let me draw another one. There should be another table for storing teachers' data. So assume this is the teacher table. It has fields too, right? Maybe teacher number, teacher ID, right? Teacher name, right? Teacher date of birth. So they are related to teacher. So students' data are saved in students table. Teachers' data are saved in teachers table. But in addition to them, there should be some other data. So if they are related to payment, you know, payments cannot be saved here or here because they are different things. So there should be another table created. Create another table in the name of payment and also create the relevant fields, right? This is payment table. We don't know the fields, right? But there should be fields, maybe receipt number, amount. So there may be some. If it is physical resources, there should be another table for storing physical resources. So remember, it is impossible to keep all the data in a single table. So definitely we need multiple data for storing multiple, we need multiple tables for storing multiple data, right? So now it would be better to take my last conclusion, last relationship. Listen to me. So this is one table, student table. This is teacher table, right? This is payment table. This is physical resources table. So when all these tables are collected together, when you see all these tables as a whole, how it looks like. You have student table, you have teachers table, you have payment table, you have physical resources table. All these things are in your school. So as a whole, collection of these tables can be called what? It is called a database. Earlier, when we describe the term database, I used to describe like collection of well-organized data. It's okay, right? That is, of course, it is correct for, I mean, in terms of definition, it is correct. But now, even you can drag the definition now and try to understand that it is correct. So now what happens? The school has to maintain a database. So school has so many data, teachers data, student data, payment data, physical resources, and so on. So to keep, look, so to keep all this data, you need so many table, right? So you need student table, teachers table, then physical resource table and payment table. So now I can write, this is student table. So this is table 1. I used to write T1, table 1 plus we want another table, right? Teachers table T2, right? Plus payment table, that is table 3, T3, plus physical resource table, that is T4, right? So T1, T2, so collection of tables. What is it? It is called database. So like I explained, so in your school, right, the teachers details are in teachers table, students data in students table, payment data in payment table, and physical resources are in physical resource table. So when we combine all these tables together, that is the database. So this is the last conclusion, relationship. Collection of table is called database, but sometimes the database is called relational database, right? Yes, the the term database is okay, but sometimes it is called relational database, right? It means the tables in the database may have connections, may have relationships, because there should be a connection between teacher table and maybe payment table, student table and payment table, maybe teacher table to physical resources table. So that is called relational database. Okay, now come to that point. So I have shown here. So I have extracted from your book. So starting from the bottom, look here. So field 1, field 2, field 3, field 4, any number of field, right? It may be field n. So what are they? When fields are combined together, records are created. Record, one record, right? Fields, when fields are joined, the record is created. Then look here, record 1, record 2, record 3, record 4. So when all the records are combined together, as I discussed, as I told you earlier, a table is created. So that is table. So when tables are combined together, you may have so many tables. So when the tables are combined together, what is created? A database is created. That is called relational database. So try to understand this connection. So don't memorize again, just understand these things with the help of a table. So it would be better if you remember my table. So when you take the table, and these things will be stuck in your mind, right? So these are the final conclusions. A collection of fields related to one person or one object is called a record, right? If you take the first one, right, look here, this is about the data about one person. The collection of data about a person, sometimes about an object, about a thing, that is called what? A record. A collection of records is called a table, right? When records are combined, that is a table. Finally, a collection of related tables is called a relational database, right? The collection of tables is what? It's a database. So remember these important points. Questions can be asked in MCQs, right? So you remember this connection between forwards. What are those forwards? Record, field, table, and database. Okay, right. Right. Then come to the heading data type. Data type. So look here, even in the look at this example. Look at the first field, admission number. In the first field, you have data. Look at my highlighted area. All of these are data. Even in the second field, student names, you have what? You have data. These are also data. In the third field, we have data. So every field in a table has data, right? It's very simple. You can understand. See, look here, you have 3 fields in this table. Every field has data, but note the type of data that a field has may be different in a table. Look at the data which the admission number has. Look at them: 1001, 1002, 1004, 1005. All these things are data, but these are related to numerical figures, number related data. So this type of data is called number, right? This is called number, sometimes called numerical data. That is also correct. Have you understood? This is the first type of data. There may be 5 different type of data, common types available in a database, 5 different types. But this is the first one, numbers. So number data type should have only numbers. It cannot have alphabets. It cannot have symbols. It cannot have any other things, right? Only numbers. This is called number. Right. Take a look at the student names. Student names have these data. Saman, Meena, Pereira, Bimal. Are they numerical figures? Are they number related data? No. So these are not numbers. So these are called text, right? Text. So because they are letters, so it is called, the type of data is called text. But look here, if I write summon dot s, assume the initial for summon is s. So I used to write summon dot or hyphen or something. I put a dash, summon dash s. So now look at this data. It has alphabets and also it has a symbol. Not only alphabet, the student names have names, sorry, letters plus symbols now. If a data has letters and alphabets, sorry, letters and symbols, that is also called text. Don't think that text includes only letters, only alphabets. It also has symbols, right? So summon dash s or summon dot s is a text. So think there is another field in this table called address, right? This is, assume this is the fourth, right? Fourth field in the table called address, right? There is data like 1, 2, 3, right? 1, 2, 3, comma, Brown Road, Jaffna. 1, 1, 2, 3, comma, Brown Road, Jaffna. Now take a look at this data. 1, 2, 3, comma, Brown Road, Jaffna. This data has numbers because 1, 2, 3 is there. This data has a symbol. Comma is there, it's a symbol. And also this data has what? Letters, alphabets. So what type of data is this? It is also text, because text is something which is very wide. Text also includes only, text includes only alphabets. That is also text. If a data has letters plus dot, I mean symbols, that is also text. If a data has numbers plus text plus symbol, that is also text. If it is number type, only numbers, right? Don't be confused. If you have a data which have only numbers, then it is number. But if you have some data which have only letters, it's a text. Which have letters plus symbols, it's a text. Which have letters plus symbols plus numbers, it is also text. Clear? So this is second data type. Now look at the date of birth. We have 15.3.1995. So now you can understand that it is not number, because if it is a number, only numerical figures are there. So since you have dots there, it is not number. So you may think that it is a text. Yes, it seems to be a text because number there, dot there. So you can argue that it is a text. But since this date of birth has date, month, year, so it is no longer text. It is called, there is a specific data type used to describe date, that is called date, right? Date, or sometimes called date or time. That is also correct. Date or time. Even you can write date, right? That is enough because these are dates. There may be month, there may be year, but we can take them as date. But even date or time is correct. So now I described or I explained three types of data. What are they? Numbers, text, and date or time, right? But there may be two more things. Let me explain them with the help of another example. Then only you can understand. I take another example. Look here, look at this example. Right, look here. There is another small table which has students data again. admission number, names, date of birth, fee, stayed in hostel. So look at the admission number, what type of data it has. So 10, 101, 10, 201, what are they? They are numbers. Look at the names, second field. There is a data called S. Vimal. There is another data called K. Kabil. So what are they? They are text. Because text includes both alphabets and symbols. Date of birth 10/1/1990, 5/7/1991. What are they? Are they text? No, because they are related to date. So what is the data type? Date or time. Even date is correct, right? Right. Take a look at the fee. So look at those two fee. 500, 500.00. I have used the sense too, right? It looks like numbers, but they are not numbers because we have dots there. So it looks like a text also because numbers as a combination of number, symbols. So you may think that it is a text. It is not text because if a field has data related to money, right? If a field has data related to money value, it may be dollar, it may be euro, it may be rupees or whatever, right? So if the data related to money, then it must be what? It is currency. This would be our fourth data type. Earlier we described three: number, text, date or time. This is our fourth, currency, right? Money related data should be currency. Okay, right. Look at the last one. The field name is stayed in hostel. That is the field name, stayed in hostel. So if a student stays in a hostel, it would be yes. If a student doesn't stay in a hostel, it must be no. So you know this field should have only yes or no. There is no other option available because this table has students data. So definitely a student sometimes stays, sometimes doesn't stay. So yes or no possible. So if a field has only yes or no in a field, right? If a field has only yes or no data, then it must be called Boolean, right? Boolean. Boolean means, even in logic gates we discuss about Boolean, right? 1, 0. Right, 1 is having electricity, 0 means not having electricity. Similar idea here, yes means that 1, no means that 0. So it is called Boolean. Have you understood? So it seems to be a text, yes, no, yes, it is text. But since only yes, no are repeated again and again, it must be called Boolean. So we have 5 types of data. These are common data types. A database may have some other data types too, but these are the most commonly used data types. Number, I'm taking them again. So data related to numerical figures only are called numbers. Data related to text plus symbols plus numbers, right? A combination, it is called text. Data related to date or time called date or time. Sometimes only date, sometimes only time, sometimes both, right? Date or time. And then fourth, data related to money should be currency. Finally, data related to yes or no should be Boolean. So we have these 5 different data types, right? And also look at this. Right here, I have put them in a different manner. Okay, all of them are same, but I used to describe in a different manner. Look at them. First one is called numbers, right? But there may be 2 types of numbers: integer number, real number. Integer number means whole number. Number without decimal places is called integer number. It can be plus or minus, positive number or negative number, but whole numbers. Don't forget that, whole numbers. Look at that example: 100 minus 34, 65. There cannot be any decimal points. These are called integer numbers. Real numbers are the numbers which have decimal points, right? So maybe plus, maybe minus, but decimal point 23.75, 67.33, minus 45.67. These are called what? Real numbers. So number is always related to numerical values, but number may have real number or integer, right? Then text. As I told you earlier, it may be only letters, maybe combination of letter, numbers, and special characters. Special characters are symbols, right? Look at the telephone number 021 dash this one. This doesn't look like a number because yes, most of the things are number, but see there is a hyphen. So hyphen is a symbol. So this is text. Look at that NIC number. Majority of the characters belong to number format, but not there is an alphabet at the end, V. So that is no longer number, right? So that must be text. Number plus alphabet, right? That is text. Even the name summon, it has only letters. That is also text. Okay, text is not a small one. It's a wide range of data type. It can have only letters. It can have letters plus symbols. It also has letters, numbers, symbols. Then currency. So any money related things, right? It may be rupee, it may be dollar, it may be euro, it may be yen, anything. Okay. Date or time. These are related to date or time, right? See, if it is 15/3/2000, even you can say that is a date. No need to show date or time. Even if it is date, it's enough. But often we used to write both of them as together, date or time, right? It is not and or time, or date, put a slash, time. Okay. But even if you say that it is date, people will accept. Look at them. It is time. So if someone gives this data and asks you to find out the data type, you must say that it is time. But again, date or time is correct. Okay. Finally, Boolean. So these are related to true or false, or yes or no, right? True, false, yes, no. These are called Boolean values. Okay. Right. So I hope that you understood these things, right? So let me take one final question to, wind up today's lesson. So there is one, often things are asked in the past paper about these basic things, right? So I have taken one simple question in order to show the method or the model for you, right? So specifically in MCQ. Answer the questions 1, 2, 3 using the following table segment that stores details of some students of a school, right? So look here, student number there, name there, date of birth there. Look at the first question. How many records are stored in the given table segment? How many records? So hope you remember the term record. So you know records are always horizontal components, which mean rows. So tell me how many records are there? This is one record. This is another one. This is another one. This is another one. So how many records are there in this table? There should be 4, right? So the answer would be 4. Okay, so it is the answer. How many fields are used to store the data in the given table segment? How many fields? So, you know, fields are related to vertical things, which means columns. So this is a field, this is another field, this is another field. Student number is a field, name is another field, date of birth, another field. So how many fields are there? 3 fields, right? So they are 3. Okay, 3. What is the most suitable data type for student number? Right? What is the most suitable data type for student number? Currency, number, date or time, text. So student number. So tell me what's the most suitable data type? Take one student number as sample. So look at this, the student number S 2010-01. Does it have alphabet? Yes, S is alphabet. Does it have numbers? Yes. Does it have symbol? Yes. So as a combination of letters, numbers, symbols, what is it? What is the data type? It is text. You can't say it is number because symbol there, alphabet is there, right? So it is called what? It is called text, right? The last one. Okay, so in your final examination, specifically in MCQ, such questions are often asked, not once, not two, right? Many times, most of the times they gave such simple questions, and you could easily answer to them. Okay, so in today's lesson, I have covered some of the most important things related to database. They are important for our next lessons, and also they are important for your exams, final exams, right? Again, take some time to watch and understand the things carefully, right? If you have doubt, ask me, or you can even text me. I can explain, or I can clarify your doubts in the next class, right? So it's enough. So we conclude today's lesson with this, and I will move you, right? Thank you.